Hey everyone, it's Tim here at Instaclustr. I hope you're doing well. Welcome to the next episode of InstaBlinks. And today we are here to talk about all things Terraform. And to help me, I am joined by one of Instaclustr's senior software engineers, Arjun Raj. Arjun, thanks for coming along.
Thanks for inviting me.
So look, we're seeing a very broad adoption of Terraform within the market. Can you just start off by telling us a little bit about what Terraform is and why it's been so popular in the market?
Terraform is an open sourced infrastructure as code tool, IAC, that helps you make changes to your infrastructure in a predictable manner. This could be done in the form of actual code files or configuration files, which might be in JSON or some other format. But ultimately, it is a declaration of what your current infrastructure should look like. And the benefits of doing this through code is that you'll have all the benefits of version control, code reviews, and things of that nature.
Okay, that makes a lot of sense. And so one thing that I've noticed about Terraform is that it's got a very big emphasis on DevOps first. How does Terraform assist in the success of a DevOps framework?
So the great thing about Terraform is that it's been widely adopted and it's had a sort of snowballing effect where lots of existing cloud providers have created Terraform Providers on Terraform, so AWS, Azure, and so forth. And so for a DevOps perspective, it becomes really easy to use this single tool to provision different resources. These resources can be virtual machines or firewall rules or AWS and security groups, for example. It makes it very easy to create these things through this standardized method. Also because all of these different providers understand the importance of this new adoption, they go through a great deal of effort to make sure that it's very, very usable. Because it is in that common language, the HashiCorp configuration language, HCL for short, it makes it very simple for someone to quickly get on and start coding and making changes to infrastructure or adding new things to the infrastructure. Precisely because, as I said before, it's a declarative language. And so you don't need a great deal of coding expertise to understand what the code says because it sort of explains itself. It's very simple to understand.
Okay, interesting. And so in terms of the provider, in terms of the end host for whatever function you're declaring on Terraform, is it very much infrastructure agnostic or does it lend itself better to one particular type of cloud or end hosting environment in particular?
So that's a very good question. I wouldn't say that Terraform is completely infrastructure agnostic. So you can think of using Terraform as using a bunch of libraries that these providers have created. And so the way that they've defined those libraries can differ from provider to provider. But it also is sort of transferable between providers, as in the knowledge of Terraform itself can carry through, but you will be required to have some form of a prior knowledge about the ins and outs of the cloud provider that you're working with in order to make a good configuration. So the language itself is shared, and so it is easy to get into, but there would be some specific bits and pieces relating to different hosting services.
Where are the benefits that Terraform has over competitors in the space?
So first of all, Terraform is open sourced. Also, it has a really wide adoption to begin with, and as I mentioned before, that has created a sort of snowballing effect. The other thing is they've gone through a great deal of effort to make sure that Terraform is very smart in the way it works. And so the sort of features that they've built right out the gate were very attractive for people in DevOps, especially with the way it handles something called a state. So Terraform manages something called a Terraform state file, which represents what the current state of your infrastructure is like. And so Terraform is as simple as using just 4 commands, really. Terraform plan, apply, destroy, and import. The state management is handled by Terraform itself. So what that means is when you make a change to the code, you don't need to worry too much about what your current infrastructure looks like because Terraform's keeping track of that for you. And so when you make a change, And when you apply that change, it will automatically update the state accordingly, and it will actually carry out those changes on the provider.
With any of these tools, and especially with open source tools, there's a level of complexity that can be, I guess, inherited when you use these kind of technologies at scale. So would you mind maybe giving us a view of some of the main gotchas that you think users should be aware of when adopting this tool?
Yep. So there are a lot of gotchas, but I will go through the most common ones that you might face as a beginner to Terraform. The dry run is extremely useful, but it does not necessarily guarantee that the changes that you apply will work. And that is because a lot of these providers have API requests and so forth that Terraform wraps around. And some of those API requests have validation rules happening in the background that can only really be triggered when you execute the plan. For the most part, a dry run should be good enough, but there might be situations where it might not work out. So in those events, it will fail, but it's not going to destroy anything. It's going to handle it pretty gracefully. Also, if you're working in a collaborative environment, it's important to make sure that your Terraform state file is stored in a remote location so that regardless of whoever is executing the Terraform code will be able to use that shared state. Additionally, it would be wise to use something called state locking, because that'll make sure that only one execution is happening at a time on a specific set of resources. And it's very smart in the way it does that. So it makes sure that two different people aren't running conflicting changes to the code at a time. Furthermore, one gotcha that you will very likely come across is that if you upgrade your Terraform version, you cannot downgrade it without doing some manual changes to the state file. And in line with that as well, it's good to pin down the versions of providers and modules that you're using in Terraform so that things might not behave differently to what you expect after you do an upgrade.
Yeah, okay. Always good to have some caveats there for people who want to go and use it in anger. So, Arjun, you've also recently been involved in the development and kind of optimization of Instaclustr's Terraform Provider. So would you mind talking to us a little bit about what that is and kind of what it's helping bring to users of Instaclustr and technologies like Kafka and Cassandra and those sort of distributed data technologies that we support?
Yep. So Instaclustr has its own provider for Terraform. It's on GitHub. It's called the Instaclustr Terraform Provider. What it allows you to do is it makes it much easier to use Instaclustr in a way that you can manage the clusters that you want to provision in our service. So we already provide a good deal of API endpoints that can be used, but this is a great alternative to it precisely because of all the advantages that Terraform brings forth. And so with Terraform, you can provision Cassandra, Kafka, all the bundles, all the clusters that we provide through Terraform, and you can peer review that. You can make sure that if you need to replicate it for different environments, you will be able to do so very easily using Terraform because you already have those configurations set up. I'd also like to add something, which is our Terraform provider is open sourced, and we welcome any issues to be raised and contributors to make a PR. We're all for that, and you're more than welcome in. Yeah,
fantastic. And I'd also say to any users of Terraform out there that are interested in having a chat, I'm happy to organize some time with Arjun and any other engineers within Instaclustr that you're keen to have a chat with about your adoption journey and any challenges you might be coming across with. So Arjun, thank you so much for your time today. It was great to get some insight into Terraform and all the goodness that it brings to the community. So thank you for all your work, and no doubt we'll be speaking again soon.
Thank you very much. It was a pleasure.
Fantastic. Thanks very much, guys. And remember, always be clustering.